This is the data science project lifecycle, right? So pretty much how we go through a data science project, the different steps that are actually involved, right? So we have a so first thing that we try to do is one of the most important parts and a big part of what we did today as we went through the different case studies. I think you can all relate to this diagram a lot better in where we stand today. So first we do data discovery. We define the problem statement, right? I know it sounds very cliched, but it's very, very important. You have to define the problem statement correctly, because if you do not define the problem statement correctly, everything downstream will go for a toss. Because you have to be very clear, what are you trying to solve? Are we doing regression? Are we doing classification? Uh, because only when you define the problem statement correctly will you know what kind of data is needed, right? So the data requirements are also very, very important. So this is the first thing that we are doing. We are trying to define the problem statement correctly. And then we try to identify the different types of data sources, what type of sources are there, how do we connect to the different types of sources. This is the part where you will do the pre-processing, what I was mentioning, right? You might have a data from multiple different sources, and you will have to figure out a way to join them. You will have to figure out a way to combine the data coming from different sources, right? So next phase, after you ingest your data, because data will come from different platforms. It could be CSV is a very common file format that is available in the in the web. Any system that you are using, CSV or comma separated value is a very popular file format. So, from anywhere you can export to a CSV and you can work with it, which is why in data science projects, CSV is a very, very popular file format to work with. And you have to understand, like a lot of times people ask this question that, okay, what about working with real-time data? You have to understand these are static models. Okay, so all that we are trying to do, we are trying to take the data that is available until a particular point in time. Okay, if you're trying to, let's say, work on something in your project, okay, you have to take some static data, because every minute, every second data is getting generated. Okay, so the traditional machine learning that we are talking about here, you cannot work with dynamic data. You have to have some data available in a static file like a CSV up to a point in time. So let's say you say, hey, I have data until yesterday. So yesterday 12 midnight, I have data available, and I will use that data to do my development workflow. And now your development sprint starts for 2 weeks. You take your data, clean your data, build, try different models. Okay, but all of what you're doing, remember, is from data that you collected latest as of yesterday. Okay, so that is why whenever you're training machine learning models, it is very important, and even in your documentation, it is very important to state what kind of data you have taken. Okay, and what is the overall uh, recency of your data. If I have to relate it to something, like all these GPT models or the language models that we tend to use. Okay, so in all these language models, also you will find something very similar. Okay, so let's say, for example, if I look at a GPT model, right? So I can give you one example. I can give you one example in terms of what I'm trying to ask here. So yeah, this may not be so relevant for now, but just so that you can relate to it, that all the models that you're building, be it machine learning, be it deep learning, be it generative AI, all the different types of models, you will have a certain, uh, so you'll have a certain overall, recency, and you have to specify explicitly, what is the recency? What is the recency? You need to explicitly specify that. Okay, and that's an important thing to overall keep in mind. Okay, so until what time was my data available? Okay, so what I did is I went to my Azure portal. Okay, so these are things I'll teach you later as we go along in the session. So you can see that I have a GPT-4 Omni model that I've deployed. So don't worry about these things right now. So this is not Chat GPT, but this is actually the development interface inside Azure. And what I wanted to show you is, let's say if I ask a question, who is the current US president, right? So if I ask, who is the current US president? So, I mean, obviously, what are we doing here? So we are using, behind the scenes, we are actually using a model which is called, so so behind the scenes, we are all using a model which is a GPT-4o model. And you can clearly see the version is 2024. So this model was released in 20th November 2024. This is the version of the model. That means the data that OpenAI used to create this model, because this is also the ideas of machine learning are very similar. Although this is something else we are doing and all that, but the core ideas are still the same. You take some data latest as of 2024, and using that you build a model, right? Using that you train a model. They would have taken a lot of time to train the model based on the data that they collected as of that day. And now what we are doing is model prediction. So I will type a prompt. I will type a prompt, and this is now hitting that deployed GPT model that is already trained. Okay. And what is happening? Model.predict. So this is like the X, GPT.predict will happen, and we are getting the Y. This is pretty much the workflow that is going on in a typical large language model, right? Think of it that way. Now, if I ask this question, you'll see that I'll get a response which says it's Joe Biden, right? Look at it. And this is very interesting, right? Now, as of my knowledge cutoff in 2023, it very clearly this language model, this the version was 2024. That's different because the knowledge was collected latest as of 2023. So this is the point where the data was freezed. It's always static, right? It's not dynamic. There are other ways to make it dynamic. That's a different thing. That's an agentic system. That's a different conversation. I'm not getting to that right now. But all machine learning, deep learning, generative models, inherently we are working with static data. Up to a certain point in time, the data was collected, let's say in some kind of a CSV file. I'm just giving an analogy right now. So you have some kind of a CSV file where that huge amount of internet scale text data was collected. And on that, you trained the model. You took a lot of time to train the model. So you can see OpenAI freeze the data in 2023, October, and they took almost a year to release. That means in the span of that 1 year, they were doing a lot of things. They were trying to train the model, fine tune the model. They did a lot of things in the span of that 1 year on the same knowledge data that they collected. And then finally, after 1 year from the data, they release the model. Okay, you can already see the amount of gap. Okay, and then obviously the more recent models like GPT 4.1 and all are trained on more recent data. Okay, so same for machine learning and deep learning tasks also. You will always be working with some kind of static data. It could be a CSV file, which is the very popular file format to work with. So the data is always static and it's always stale up to that particular point in time till which you have collected the data. And then you have to retrain the model. A very important concept in machine learning is model retraining. So you take some data, use some algorithm, build a model, whatever we have done in all these demonstrations and case studies. And now the next thing that you try to do is you try to retrain the model. Now you try to take some sample data and try to retrain the model. You try to take some sample data and incremental data and try to retrain the model. Make something better. Make something better. So how you can retrain the model based on the incremental data. So that's another something that to keep in mind. Okay. I will talk a little bit about Azure as we go along. So we have enough time for that. So we'll come to that conversation. So for now, let's go back to the uh, the algorithm. Before that, I was discussing about this. So data discovery, ingestion. Then you go to data wrangling. This is the part where you pre-process the data, you prepare the data, right? So this is the data wrangling part that you do. So you take the data and you pre-process it. You remove missing values, remove outliers. So it's a bit of basic blueprint that tells you what are the different steps involved and what are the different things you broadly do, right? So this is the part where you look at the skewness, you try to apply power transforms, you try to scale your data, right? You might want to join or merge your data if your data comes from different sources. So all those things we will try to do, right? So yeah, data exploration is the part where you try to create some charts, you try to create some visualizations. So correlations, scatter plots, histograms, all of these things broadly we have seen, right? It is very, very exhaustive, but what I tried to do in this summary is to highlight some of the key things that we try to do. But it's an exhaustive list. If you Google out, there are hundreds of different visualizations that you can create in Python. But these are some of the most important ones that you look forward to. And then we come to model building, model selection. This is the part where you try out different algorithms. You try building different models, all of what we have talked about, right? So prepare, train, test, decide on supervised, decide classification, regression. So build the model, predict, find out the performance, compare the performance of different models, right? Boost the performance of the chosen model. How do we do it? We do it by hyperparameter tuning. So this is all a set of steps, right? So you build a model, evaluate the model using confusion matrix, accuracy. training, testing scores, cross validation, right? And then you try to use hyperparameter tuning to boost the model performance. So once all that is done, now we move the model to production as a pickle file. Now this part we have not seen. This part we have not seen. I will discuss that later. How to productionize a machine learning or deep learning model. We'll see that on the last day once I complete deep learning. So once you're done with the whole thing, you take that that sklearn object, or you take that keras object, which is nothing but a simple Python object. Okay, you have a variable. So right now you have a variable in Python. It's like an object in Python. Now you take that Python object and you serialize that into a pickle file. Okay, because you need to move it, you need to deploy it, right? So for that, you need to first convert it to a pickle file, and then you deploy it. This is the part we will discuss later on. Okay, and finally, the last part is explainable machine learning. This is the last step where you try to uh, explain your machine learning models to your stakeholders, right? So for example, all the business cases that we talked about, lead scoring, and all that we discussed in the course of the last few hours or so, and all of this ultimately you need to present to your stakeholders, right? You need to explain the results of these models to your stakeholders. Okay, your stakeholders need to see what exactly you did. That's the whole idea.